Okay guys, welcome to our next lesson for 5-day 3. We are still on exponential and logarithmic equations. And we've been working with significant digits, but just a little bit of review for you guys. All non-zero digits are significant. So anything that is not a zero, always significant. All zeros that are between digits are significant. Okay, so if it's like 103, that zero is significant because it's between two other digits. All zeros to the right of the decimal point and to the right of significant digits are significant. Okay, so today in your answers, they're going to ask you to round to 3 significant digits, and that's why we're just doing this little bit of review here for you. Now keep in mind, there are still 2 ways to solve. We can either graph or use algebra. Okay, we are going to focus on algebra today, but a reminder of graphing for those of you that prefer graphing. The reason I'm focusing on algebra is because I know that you can figure out graphing on your own. We did a whole lesson on it, so you can go back and watch that lesson. It was day 1 if you want to look at graphing, but this is just a reminder for you guys. In order to solve by graphing, graph the left side of the equal side, or of the equal sign, graph the left side of the equation into y1, then graph the right side of the equation into y2. You'll go to second trace intersect. Make sure you have an appropriate viewing window where you can actually see the entire graph. And then where those curves intersect, that would be your solution, and you always want the x value. So you would tell me x equals for your answer. Okay, so if you want to solve by graphing, you can always do that, but we are going to focus on the algebra piece. In my opinion, it's going to be much faster and easier. So here are our tips for solving algebraically. The first one is to cancel out any logs. If there are logs on both sides of the equation, you can just cross them out. Combine logs into 1. Remember, if logs are being added, you can combine those logs using multiplication. And if logs are being subtracted, you can combine those logs using division. The last tip is to rewrite logs into exponential form. We're going to be doing that in almost every problem. And then keep in mind, once you have your final answer, you cannot take the log of the number 0 or of a negative number. So if you happen to get a negative number or the number 0 as your answer, it might not be a real answer, okay? And here we go. We have some problems, and I believe we have maybe 4 or 5, and then that's it. Solve each problem algebraically and graphically. Again, like I said, we're going to focus on the algebra. And round answers to 3 significant digits. So the first thing that we are going to do here is rewrite this problem in logarithmic form. So remember, whatever is the base of the exponent is going to be the base of the log. So we're going to have log base 1.05. Whatever number is by itself is what you're taking the log of. So log base 1.05 of 2 equals x. So now you can put all of this right into your calculator. Remember, to get a different base, to get the base of 1.05, you have to go to that math button and scroll down, okay? And then that will allow you to choose a separate base. And so what we end up with is x equals 14.206699. And now if we want 3 significant digits, 1, 2, 3. So my final answer, x equals 14.2. Okay, guys? Again, could you have graphed the left side in y1, the right side in y2? Of course. I personally think this algebra is much faster. You guys can do this much easier than putting all that in the graph, dealing with second trace intersect. All right, here is our next example. All right, guys? So now for this example, again, we are going to start with rewriting it in logarithmic form. So the base of the exponent is going to be the base of my log. So log base e. Whatever is here on the right by itself is what we are taking the log of. So log base e of 13 equals negative 1.4x. Now remember, log base e is really natural log, ln. So I really have ln of 13 equals negative 1.4x. So now from here, to get my x alone, let's divide both sides by negative 1.4. And so what I end up getting is x equals negative 1.8321. Now the directions tell me to go to 3 significant digits. So 1, 2, 3. My final answer is x equals negative 1.83. So how nice and simple is that? Okay, guys, we should be able to go through these problems easily, and there really is no need to graph to find the intersection. You guys can do this algebra and do it well. I have full confidence in that. All right, let's go to number 37. This one's slightly trickier, but you guys will be fine. You can do this, okay? And the first thing we are going to do is subtract the 5. Okay, so you do want to get rid of that extra 5 there. So we end up with 3 to the power of x. So I have 3 to the power of x equals 5. Now from here, I do want to rewrite this in log form. Remember, the base of the exponent becomes the base of my log. So log base 3, the number that's by itself on the other side of the equal sign, is what I'm taking the log of, and my exponent comes over here by itself. So log base 3 of 5 equals x. We literally just put that into the calculator. Okay, remember, for the different base, go to that math button to make sure you can change the base. All right, and when we put that in the calculator, we get x equals 1.46497. Remember, the directions tell me 3 significant digits. So 1, 2, 3. And my final answer is x equals 1.46. All right, guys, so flying through this, right? Solving this algebraically is nice and simple. That's why we're focusing on that today. Okay, guys, so let's take a look here at number 39. Again, we are focusing on the algebra. This is going to be very similar to the last problem that we did. The first thing that we are going to do is add 7 to both sides. So when I do that, I end up with 10 to the power of 2x plus 5 equals 20. From there, I am going to rewrite this in log form. So I end up with log, the base of the exponent is also the base of the log. Whatever number I have here on the right is what I am taking the log of, and my exponent goes all by itself on the other side of the equal sign. So there is my logarithmic form. And from here, I am just going to actually put this into my calculator to figure out what log base 10 of 20 is. And that gives me 1.301 equals 2x plus 5. From here, right, we just have a nice, easy algebra problem. So I subtract 5 from both sides, and I end up with negative 3.699 equals 2x. From there, I divide both sides by 2. And when I divide both sides by 2, I end up with x equals negative 1.8495. Now notice my directions tell me to use 3 significant digits. So I have 1, 2, 3, but be careful of that rounding rule, okay? Because the 9 follows that last digit, we do want to round up. So my final answer is x equals negative 1.85. And there we go. All right, guys, be careful with rounding because the test will try to trick you, okay? It will have an option of negative 1.84 and negative 1.85. All right, so be mindful of that. All right, this is our second to last problem. Okay, guys, this one and one more. So for this problem, the first thing we are going to do is we're going to divide both sides by 500. So let's get rid of that 500 that is there. So when I do 123 divided by 500, I end up with 0.246 equals e to the power of negative 0.12x. Now I'm going to go ahead and rewrite this in log form. So I end up with log, the base of my exponent is going to be the base of my log, so log base e of whatever number's over here is what I'm taking the log of. Log base e of 0.246 equals, and then I put my exponent on the other side of the equal sign, equals negative 0.12x, okay? Remember that log base e is really just ln, so I have the natural log of 0.246 equals negative 0.12x. So in order to get the x alone, I just divide both sides by negative 0.12. So let's divide by negative 0.12. And when I do that, I end up with x equals 11.68686. Now my directions tell me to go to 3 significant digits. So 1, 2, 3. Don't forget your rounding rules, okay? Since there is an 8 after that third significant digit, we are going to round up. X equals 11.7 would be my final answer. All right, guys? I hope it's making sense. I hope you guys are enjoying it. I know most of you like this pure algebra. All right, so we have one more problem, and then we are done with this lesson. All right, let's look at our very last one. Okay, so right away, the first thing we are going to do here is rewrite this in log form. So I'm going to have log, the base of the exponent is always the base of my log. So log base e. What is over here is what we're taking the log of. So log base e of 0.23 equals, the exponent is what we put on the other side of the equal sign, equals negative x squared. All right, so remember log base e is really the natural log of 0.23 equals negative 1 x squared. So this is an invisible negative 1. So to get that x squared alone, let's divide both sides by negative 1. Here on the right, they cancel out, and I end up with x squared equals 1.4697. Now my last step, to get the x alone, I square root both sides, and from there, I get my final answer of x equals plus or minus 1.2123. Okay, guys, don't forget that. You guys are in college algebra, right? We should know that. The square root of a number is always positive and negative, so that's why I put my plus or minus. Now I want 3 significant digits, so 1, 2, 3. So my final answer is x equals plus or minus 1.21. Boom. There you guys go. So we've seen a ton of different examples here of how to solve algebraically. Here is your homework for 5-day 3, page 449 in the textbook. It is only 6 problems. Okay, guys, numbers 34 through 44 even. Make sure we submit all of that in Google Classroom. And thank you all for joining me for this lesson. I will see you guys for the next one.